Let's talk about the code builder. You would be writing your application server-side application programs under the grouping here called business flows. And within this, there is a very large variety of stuff that you can do. And I will point out all the features which require you to write code using the code builder, which is server-side programming language of ZOAPIIO. So an entry point is entry point you're familiar with. It's a REST entry point, which means the input is HTTP, either GET, POST, or a request URL. Then there is an entry point SOAP, which means you can write SOAP services. SOAP services are slowly going out of fashion, so chances are you will be spending most of your time doing this, the entry point. Then we also have GraphQL support, which means that if you're writing GraphQL services, you can do that. Then there are JMS, which is the message queue entry points. You can write services which handle JMS messages. You can also handle, or you can write a service which monitors an email account and automatically processes the incoming messages. You can write WebSocket services. And this Proclet is a proprietary ZOAPIIO abstract, and I'm just going to not talk about it in this section. But these are chances are you're already familiar with the rest of it. Then we have something called a routine. I'm sure if you've done some programming, you know what are subroutines. So you build a subroutine to write reusable, simple blocks of processing. And routines are also built using the code builder. A method is similar to a routine, except that this is written in Java. And since today we are focusing only on the code builder, we will not touch on this. We will come back here in a different segment. Then just to walk you through this, you can use XSL transformation as a part of your processing. And then we have web applications and mobile applications. You can add those here as well, which we will be discussing in another segment. So today it's going to be about routines and most of these entry points. So let's just open up an entry point and see what we get to. Right, so we get you need to define a bunch of parameters which fully describe how your entry point will behave, starting with the URL. So let's say I just give a URL which is /wc, and wc is a mandatory prefix because we have multiple types of entry points. System needs to know wc means that this is a REST web service. That's it. I can use a larger path if I want. Then you have to say what kind of response the service has. You have options of JSON, XML, plain text, binary data. You can also return from the service, and file. So the request path you have to define from your schema as to where the input coming to this service should be placed. And by default, it points to request. You can make it point somewhere else if you prefer. Similarly, you have to give a response path, and this is mandatory. So let's just give response, which means whatever is under the response node becomes the response of this service. And how am I expecting, in what format is the input expected? It can be post data XML, post data JSON, post data text, or it can be part of the URL. Then there are some other options which are, I would say, advanced, and we'll just skip over right now, except that we'll assign a logger, trace logger. When the service executes, it'll generate a trace log, which is very useful in debugging. So you should always assign a trace logger while you're testing your applications. And that's it. Now we have created the first API, or just the skeleton or the definition of it. Now we have to start writing the code. And so before I continue, let me just also add a routine, because the routines are our tool to keep uh, the each process to a manageable size. As a thumb rule, what I suggest is any piece of code that exceeds the size of your screen, or one page full of your, this is the one page we are looking at, anything that exceeds this, that means you should probably create a routine and move some of the logic to a routine. Routines can have two parameters, input and output. Let's just leave it blank right now. So now I want to start writing code for this API. So I can do a right click and say edit, or sometimes it's just easier to drag and drop this into the code window. And now I have this blank window in front of me where I can write code. And here is a control panel for me to start adding logic to my program. And the most common one is the compute. Okay, so I can take this, drag and drop here, which means I want to perform some computation. Now, what do I write inside this? Obviously, it's the computation that I want to do. And how you write this is like expression in any other language that you have used. For example, I can say x equals 1. Now, this is an expression which you might be familiar with if you've done programming. It's a simple assignment. But here you see this is flagging an error. It says invalid path. So that means where we're saying x, it expects a reference to some element in your schema. Okay, so let's say under variables, I have some declarations. I, J, K, L, M, these are integer nodes, and A, B, C, D, they're string. It's just, you can say that this is my local processing area. So here, if I say slash variables slash I equal to 1, our system is happy. So what I've done is I have taken a particular element in my schema and assigned it a value. Similarly, I could say, for example, assign a value to this. So I can do a clone. I can duplicate this, get another compute, put it in front of it, and our program will go sequentially. So here I can say slash response slash I made another assignment. So the effect of this statement is that the response node would be created, the name of the element node would be created, and a value would be copied to it. This is how you write a program. And so, for example, if I want to, I can write multiple compute statements in the same line, and I have to put a comma at the end of every statement. And here I can say slash j equals slash I plus 5. This is another assignment, but it also includes a computation, which means adding 5 to the value that I put under I. Now this is, I have to write a full path, or starting from root, to identify the element that I'm talking about. So there is a way to shorten this, and that is, for example, we have some blocks. So we have a for each block, we have a with block, while, and if. These are, you might be familiar with all of them. They are standard programming constructs, except with you might not have come across. So let's take an example of this. I'll bring it in here. Then I will move this in here, put it back here. So now what I want to say is with slash variables. compute I is equal to 1 and j is equal to I plus 5. This is perfectly legitimate. Because what I'm saying is that this compute statement is under the context of the variables node. Now, inside anything that any name that is not a full path name is assumed to be relative to the context node. But I can, of course, use a fully qualified path. So, for example, I could take this whole thing and also put it here and delete this altogether. Here, I have an option of using a relative path or the fully qualified path. Now let's see how we reference elements of an array. So, for example, in the response, there is a member which supports duplicates. So, for example, I could say duplicate it here, and I can say compute slash response slash member, and here I can give an index. Essentially, what I'm saying is that member is an array, and I want to reference the first element. So, a word of caution here: if you have programmed in languages like Java or JavaScript, you know that the array index starts from 0. But here, the array index starts at 1. Just keep it in mind. And in fact, if the array index is 1, you can just skip it entirely. It defaults to the first. And for example, I want to say true. The compute statements work like the expressions that you have come across in any other language. The only difference is the participating elements or data elements actually reference elements of your schema. Now, if I just did this in my service, which is, you can see here which service I'm editing, and I saved it, and I ran this service, I would get whatever I'm putting in the response, that members will get 2-member array, and this will be, let's go back and take a look. This will be rendered as a JSON. So the output of this would be a JSON, and it will contain exactly what I have put here. This is all, none of this, okay, this element also gets created, but everything else I just used to show how to do the assignments. Then now let's look at some other things. Let's look at control. So some control statements we have is when you are inside a loop. So before we do this, let's get into a loop. Say for each. So now let's imagine we have received an input which contains an array of members, for example. Okay, so let's do this. Let's copy this and copy it under request, for example. Means, and because it is a structure, we need to go back to our API, and we can perhaps change it to post data JSON. Okay, which means that when we call this service, we can actually pass the structure as a JSON. And if it was not a nested structure and just, let's say, 1 or 2 elements, we could have used the request URL. So now let's say we're getting a request which has multiple members in it, and we want to process every member that's coming in as request. So here we can say for each /request/member. And I can pick a loop variable. And this means is that I'm iterating over all the member nodes which arrived as input, and I want to process them. So and variable I always points to the index of the member element that I'm currently processing. And I can actually here apply a filter. So I can say, for example, under compute, I can pick a test condition. Okay, not the test, just the expression. I can throw this away. So I can put a test condition. So let's say I want to process only those members where the last name or where the ID is greater than 1,000, for example. This is what we wanted. So now we have a loop which is iterating over this list or array, and I have a little filter as well. So this is how you build your program. Is you use blocks, you use computes, and you can explore this complete menu and get comfortable and familiar with it. So I want to first show you the control. So we have break, we have continue, and we have a return, and we have a abort. Okay, each one of these are actually accompanied by a condition. Okay, so what this means is, suppose I want to under certain condition, I want the loop, we want to break out of the loop. So here I can attach a condition. If I don't attach a condition, this is an unconditional break. That means if I actually ran this, it will just enter the loop and exit immediately because I have an unconditional break. Now here I can say break if ID is greater than 2000. So that means we entered the loop and we are processing everything where ID is greater than 1000. And as soon as we hit 2000, we exit. I mean, we could have also said where ID is greater than this and ID is less than 2000. And could have done the same. Or if we want to be syntactically correct, less than or equal to 2000. So this is how we can use a break, or if we didn't have this condition here, this break would achieve the same thing. Now, similarly, we have a continue. So if you want to, under certain conditions, continue to the next loop, that means skip the rest of the processing inside the block, I can do a continue. And here also I can attach a condition. And I can put any condition. Now notice that when I'm inside a for each loop, everything inside this is using the current member node as the context. So when I say ID, it is referring to the ID of the current member node that we are processing. Okay, which is equivalent to saying /request /member ith element /id. Now, so ith element is because we are I is pointing to the current member, and this means the same, except there is a slight syntactical twist that you should remember, is always put a hash in front of the index. Because if you don't put this, it will try to take this as a number and use it, and I will fail because I is not a number. So just put a hash, which means I want to refer to the ith member under request and ID of that. But since the context node is already the ith member in the list, we can just simply do this. So this break and continue apply to a loop, and return applies to a routine. And if we are inside a service, it is same as abort. So what the abort does is, it will abort the service from anywhere in your execution stack. So if from the service you called a routine and you abort from there, it will immediately return from the service. And return will return back from the routine or the service, depending upon where you are. So if you have done programming, you're familiar with all this. Just pointing out how the code builder, how you would write these things in the code builder. Okay. Now there are some other things like the web service and the database, which I will not cover in this section because there are separate sections which deal with database handling and API handling. So right now, just I want to show you how the code builder works. Okay, it's very simple. You have to have your logic. Perhaps you should write it down on a piece of paper before you start writing. And the moment you feel that the logic is becoming big, you can just simply, for example, if I want to take this off and let's do this, I can just copy this entire code and I can go into the routine and I can paste it here. And then I can just do this and throw this away and just have this. So this is my routine. And I can go back to my API, throw this part away, and I can do, I can drag and drop this routine and say call. So it's the same thing. I've taken a piece of logic, put it in a routine, and this allows me to keep this total size of the application, the total size of each executable block to a reasonable size where you can easily understand and follow the logic. One last thing I want to sort of cover is that it is very easy to write the program in this fashion because everything is drag and drop, and you only have to sort of know what logic you are trying to express. There is a feature here which says review. Now this produces a readable format of a program, which sometimes is first of all, it's, if you want to share it with somebody, you want to email it. This is the textual representation. But sometimes you want to you find this much more readable as a logic than your block code builder. So just pointing it out, you can use this. If you want to review your code, it's easier to read. But of course, feel this is as good. So now this is all about the code builder. It is quite simple. You just have to know what you're doing. And before I leave, perhaps one last thing I can do is when you are, let's say iterating over this, what I did was I typed the name variables here. There's an option here. I can take this, drag and drop it here, and attach it like this as well. So with various shortcuts, you can drop things from your schema into a code builder, and you will typically find some shortcut which allows you to do less typing. Like for example, I drag and drop this routine name, and it allowed me to create an execute, which is from the procedures. I can do execute, call a method, proclets I'm not covering at this point. So you get the idea. So at this point, I would advise you to write an actual program. Think of some simple program, whatever, a small API, which does something. Try to think of a interesting, not so trivial, and build it and try it out in your designer. So that's it about the code builder. Thank you.